Hello everyone, I'm back again. So I'm back. This is a new live stream. I think it's just part of the continuation of what I was doing before. That was in the cloud, but now this is a separate topic, but I feel like I'm trying to connect them together. That one was about DevOps, and here is about this live stream. Basically, is about going from an idea to a fully working software. So this live stream is going to be in two parts. The first part is the documentation phase, and the second part is the implementation phase. And the first part, I will only discuss about the documentation. The documentation, what I've done, and what I have done, including all the documents I've written in order to build this software. This software is actually already working, but it's not just in production. That's the next thing. I will also show you when it is in production. Just a second. This thing is not playing. Alright, it's there. Yeah. As I was saying, I'm going to have two phases. The first phase is the documentation phase, and in the documentation phase I have a lot of information that I'm going to debunk today. I have a lot of things that I'm going to explain here. And in the implementation phase, we shall go through how I implemented this using Go and what architectural pattern that I'm using, which is basically the repository pattern. We'll come and understand more about it, how it works. So yeah, let's start from the beginning, from the scratch. Let's start from scratch and see how an idea, let's say you have an idea, or you have, let's say an idea can be an idea of a product, or it can be an idea of a feature that you need to add on top of existing product. So how do you turn that idea into a fully working software that others can utilize it? So that might be the question. You have a barrier in the middle from an idea to a software. So we shall come and see how I did that. This is based on a feature that I'm currently working on, that I worked on, not I'm currently working on. I've already worked on everything, and I will show you the demo. It is only the API, and when I connect it to the front end, I will show you guys how it works with the front end. But basically, the API, I will show you how the API works under the hood. And the real implementation detail will be in the next phase, or the next live stream. So let's start. In order to turn an idea into a software, you need several documents that you need to write, and these documents allow you to understand what actually you're working with. And one of these documents is the PRD, or it is the project requirements document. What is a PRD? A PRD is a document created by the project manager that defines the purpose, features, behaviors, and functionality of a product or a new feature. This is just a textbook definition, but in actual sense, a PRD is just like a document. Picture this: if let's say you're trying to build something, right? Or you're trying to start something, you ask yourself, why am I starting this thing? Or let's say you're trying to build a software, and you ask yourself, why am I trying to build this software? And to whom am I even building this software to? And which problem am I solving? So all these questions are asked, and they are recorded within a document, and this document is called the PRD. That's just how it is. So what are the components of a PRD? A PRD has several components, and these components are like clear problem statement. Let's say if you're trying to build a software and you're trying to include in your PRD, you need a clear problem statement. And this problem statement is what are you actually solving, because you don't have to just build something without a problem that you're solving. It will be like a waste of time. So you need to decide, what am I solving? Why am I putting time within this thing that I'm trying to build? Why am I giving it a lot of my time? So you need to ask yourself, and this question is going to be recorded in your PRD. And then the second thing is the targeted personas. Who are the audience of the product? Why are you building this product? And who are the people who are going to use this product? Because if you're building something, you need someone to use it. It's like you figured out a problem. Yeah, I figured out a problem, and to whom am I solving this problem? You need to state those people. I will give you example with the exact feature, this feature that I have built, and I will give you example of how it is. And then you need to record the functional and non-functional requirements. Functional requirements and non-functional requirements, basically, that are part of technical requirements document, but the technical requirements document is still like, as I picture it as an extension of the product requirements document. I will talk more about it, or I will talk more about functional and non-functional requirements when we reach to technical requirements document. So let me give you an example with the software that I'm building. Let's say with this software I'm building a feature. All right, this documentation is for a feature, and this feature is called course material. Right, and what the feature does is that it allows a user to attach a course material. To a course. I have course service and I have a course material service, right? And I have a user service. So let's say a user creates a course within the application. After creating the course, you don't have to just have an empty course. You need to add materials to it, right? You need to add maybe YouTube videos, or you need to add notes that you got it from somewhere else. Because the main aim of Focus Flow is to give the users structured place where they can have where they can structure their courses. So let's say I got my course. Let's say I created a course, and then I need to add a course material to it. So I have to go to YouTube. I will be given a search bar within Focus Flow. Then I will search for a course that I need. Let's say I search for Go Fundamentals. So if I get that course, and then I can add it. If I get that course material, basically that's the YouTube video, I can just add it to my course direct within Focus Flow, and then I save it. So this becomes my overall course. So this is the problem I'm solving, the problem of people being distracted by YouTube recommendation. Or let's say you're a student and you're trying to master a concept. So you open YouTube, you start watching something about what you're trying to master, and then after all of a sudden you get a recommendation of a football match, you start watching that match, and again you get another recommendation of a basketball highlights, you watch it, and then you'll be like, you just wasted a lot of time with this watching what is not really necessary, instead of nailing down what you really wanted to do. So this is the problem I'm trying to solve. That is the problem of distraction. So that is one thing you have to state within your project requirements document. You need to state the clear problem statement and the goals. I will show you with an example of a project requirements document that I have already created, but let me just finish all this. And then the second thing is the targeted personas. So let's say I've already defined the problem that I'm trying to solve. That is the problem of distraction, right? Then I'm solving this distraction to who? I have to I have to state whom am I solving this problem to. And this problem I'm solving maybe to working professionals who are ever getting distracted. Let's say I'm trying to squeeze in every minute of my time in doing something productive. So instead of let's say instead of being distracted watching other things that I don't really need, so I have to really squeeze in every 10 seconds, every 10 minutes that I have in my time to doing something productive. So that's one of my targeted personas, and The other targeted personas are the students, maybe people who are trying to, let's say, trying to learn something new, or any curious learner, somebody who's trying to learn something new, somebody who's trying to upskill every time. So these are my targeted personas. And then the functional and non-functional requirements, as I said, I will deep dive into them when I read the technical requirements document. Let me just give you an example before I proceed. Let me just give you a simple example of technical PRD. One of the PRD I have is here. PRD. I think I have it. I might have it here. I have one PRD here, and then I will show you also that the exact PRD. This is just an example of a PRD. This is an example of a PRD that I worked on before. It is here in, I just saved it in Google Docs, and then these are the sections that I have. I have the name, the project overview, the targeted personas, whom am I solving, the goals, the success matrix, what are the measurable things that I need to measure in case my product is successful, what are the things that I'm trying to measure. Then the assumption and the technical limitation. This is it here. I'm just using here Google Docs, but that is not the right way to, like, that's not the right way to me, that's not the right way of saving technical requirements document. I can show you the better way. I saved it within a product. That product is called Confluence, and Confluence is from Jira. Yeah, let me open it from here. It's from Atlassian, the same company that made Jira. It's basically it's basically a project management software. So this is it here, and then these are all the required documents that I need. So Confluence gives you one space, like it gives you a single unified space where you can save your documents. That basically these documents are the documents used for building software. All your project requirements document, your technical requirements document, your use case document, they're all saved within Confluence. And Confluence is made by Atlassian, and Atlassian is the company that made Jira. If you know about project management, I think you might know Jira. What is Jira exactly? All right. So this is it with product requirements document, and here is the exact product requirements document for that feature that I was talking about. And then here I have the name of the project, the name of the document. I have the table of content, what are the things that are inside the document. Then the project overview. As I said here, course material is a feature that allows users to attach course material such as YouTube videos to an existing course. This will utilize the YouTube API. It's simple. This is just the overview of the document. And then here I have why am I solving this. We are building this to allow users attach course, right? Yeah, I'm building this course material to allow users attach course to attach course material to a specific course. And how does this fit into our overall company goal? This is it. And the requirements, yeah, as I said, I have to state a little bit of requirements here, but most requirements are detailed within the technical requirements document, which I will talk about also. All right. So this takes us into technical requirements document. What is the technical requirements document? Technical requirements document translate the business goals into actionable technical specification for a product or a feature to be built. Yeah, that might sound vague, or it's just like a textbook definition, but technical requirements document is not really what you think. It's something just simple. What it is that a technical requirements document is a document. Let's say you have an idea, right? You have an idea that you want to build, and then that idea maybe is an idea of a product or a feature that you want to build. So any product that you have a business goal for that product, right? you have a business goal, you have what you need to achieve when you build that product. So having that idea alone is not that the product is already being built. Having that idea is the footprint, is the starting step, right? Is where you start. You have the idea. As we said, the idea is recorded in the product requirements document. This is just the starting point. So having that idea, you need a mean where you can translate that idea into technical requirements or actionable requirements. These actionable requirements are what engineers can implement. That it means that moving from business goals or business logic into what engineering, or what the engineering can do. What are the requirements? What are the things required for the engineers to do? So this technical requirements document is divided into several components, and these components include, we have the functional requirements, the non-functional requirements, the architectural diagrams, and then the constraint and technical limitation. Yeah. So these might sound vague, but let's start. Let's deep dive within each of them, and then I explain what exactly are they. So functional requirements, these are requirements, the requirements that the software can do. These are the things that the software can do. This can be, for example, a user shall be able to log in. That is a functional requirement. So you need to build a feature that allows the user to log in. This is an example of functional requirements. So an example of functional requirements from exactly from this feature that I have built is that a user shall be able to attach a course to a course material. This is what a real a functional requirement. And then the other thing is non-functional requirements. How? Non-functional requirements, this is the how question. How is our software going to do that? For example, the user experience. Let's say the application should not be able to crash if the users are using the application. This is one of the non-functional requirements. And then another non-functional requirement is that let's say a user is able to log in within 20 seconds. This is another non-functional requirements. Basically, non-functional requirements just separate real applications from simple hobby applications, because real applications are out there and they're running in production, and every mistake, every crash in the software cost the business a lot of money, that or cause the customers to leave, to stop trusting the product. So you need to put in mind the non-functional requirements. And then the third part is the architectural diagrams. These are the diagrams that show that there are two types of these diagrams. There's the behavioral and there's the implementation part of the diagram. The behavioral just allows you to map out how the application or how the components in the system interact with one another. So I will show you more about this architectural diagram. And then the last part is the constraint and technical limitation. So you have to put in mind, every product that you're building, you need to put in mind that there are some things that you will not afford. Also, there are things that, let's say, if you cannot afford, let's say, a large number of developers to work on the product. So this is another technical limitation. Or if you cannot afford the compute that you need your application to run in, let's say you cannot afford to run a Kubernetes cluster just to make your application highly available. That is one of the technical limitations. So the technical limitation, these are the things that limit you from doing something. So in every product that you're building, you have to put in mind the technical limitation that you're going to face. Maybe you're going to face the technical limitation of the knowledge that you might not even be having the skills to build something. That is one of the technical limitations. You need to also put them within your technical requirements document. So let's deep dive into the architectural diagrams. And then the first diagram I have is the context diagram. I think I have to increase the font, and then have to put this off. It's causing a lot of distraction. Alright, I think this is the last slide. Yeah, the context diagram. This is a high-level diagram that defines the scope and the boundaries of a system by showing its interaction with external entities. Yeah, what exactly is the context diagram? The context diagram allows you to see the boundaries between the entities within your system, or it allows you to see the interaction between the actors within the system. Let's say in this diagram here, this is actually part of the focus flow context diagram. This is just for the course material feature, right? So what I have here is the use case of this context diagram. Okay, I have a user here, and then I have a course service, I have a YouTube API service, and then I have here the course material service. So a user can log in, and then a user can create a course. A user can also search for a course, right? And this search course is related to a YouTube API, which means a user can search a course via the within course material service, and this service will call the YouTube API. So this just to give you like the full picture of what we are building. This is the first diagram that you need to map out. So after mapping out this diagram, you need to see the sequence of behavior, how the users are going to do this, how the users are going to navigate from point A to point B, basically the happy part of the user. So that takes us to sequence diagram. Sequence diagram is a UML behavioral diagram that models the interaction of components into a system in a step-by-step timeline. It's basically what the definition says. A sequence diagram allows you to model the behavior of the user. Let's say, let me just give you from here. Let's say it allows you to model the behavior of user from the client starting to log in, and then going to course material server, from course material server to the YouTube API server. This is just basically modeling the behavior of the user within a specific feature. So I will come and explain more about it when I write down here, but I was just showing you how it is. So the components are the actors. This could be the component of or another system. Yeah, in a sequence diagram you have an actor, and then you have a message. A message is basically these arrows that points to the actors. So the benefit, why do you need a sequence diagram, is for complex system modeling. If your system is quite complex, you need a sequence diagram to model the behavior of the user or the behavior of how the components talk to each other within that system. And it also helps you in the documentation of your application, and then in debugging. Let's say you got an error, so you can easily map out how the user interact with the application. And this helps you to spot bottlenecks and times out, and also as a visual checklist. So it helps you to see where the errors are, and see if you have a lot of times out, and see which service is the user mostly using. So here it is how the sequence diagram is. Let me first show you. You start from the client here. I think I might show you from, let me show you from this, because here is not clear. I have it here. Let it load. Have one sequence diagram here. Let's get rid of this. Yeah, this is the sequence diagram that I was explaining. Then I have to zoom it widely. Reduce it a little bit. No, this is the use case diagram. The sequence diagram is below it. Sequence diagram is here. Yeah, I think this is much clearer than that one. So you start from the client. A client is trying to search for a YouTube video, right? This is one step. After the client sends a request to course material server, right? After sending that request to course material server, the course material server proxies that request to the YouTube API server. Okay, after sending it to the YouTube API server, the YouTube API will have an alternative block here. This block allows you to, let's say, it allows you to handle exception before proceeding. So yeah, here if the video is found is then returned, then the YouTube API server return a list of videos. So these videos are then sent to course material server. The course material server sends back the response to the user, to the client. That's basically, in my case, is the Nux application that I built. So it will send it to the user, and then yeah, the user get the videos. So if the videos are not found, here I'm handling the exception. If the video is not found, the YouTube API will send videos not found, or will send an empty array to the course material server, and the course material server will send a response that video not site not found. So yeah, basically this is it from this alternate block. And then okay, after doing that, let's say after user searching for the video and then they already have that video, what next? That user makes a request to this course material service, to the course material service, to save that video within our database. So what it does after saving that video within our database, it returns JSON, that it returns the JSON response that the videos are being saved, and if the videos are sent correctly. All right, so if there is an error, it will return the error back to the user. Yeah, this is basically from the technical standpoint, but let me explain it again in, let's say, in a way that a technical person can, non-technical people can understand. Is that, let's say you logged in within Focus Flow, you search for a video, let's say Go Fundamental. After searching for that video is taken to course material server. That search goes to a server, and that server is course material server, and then that server proxies or sends that query to YouTube server. So the YouTube server returns a list of videos, and now you're happy that the video you search for is there. Then you click save within course material, and you click on that video, and then you click save. After clicking save, the application makes a request to course material server, and then the course material server saves your video, and then you're done. So you already attached a course to a course material. That is it from this point. So this is the sequence diagram, and it's actually a very important diagram to map out your logic when you're trying to build anything. And then the next diagram that is mandatory here is that you need an UML entity relationship diagram. This is a visual blueprint of database that maps out how different items called entities interact within the system. This must sound also vague, and it is also a textbook definition of entity diagram, but the easiest way to visualize this is that, let's say you have a database. Visualize that you have a database. The database is basically where you store most of what you need for your entity or for your product. Let's say you have a product, and then the product might have a name, the product might have price, the product might have a lot of things, right? So you need to store those in a database. So that is the database. So how do you do that? You need to, let's say, you need a way to visualize the data structure of that database. The data structure is basically how you structure your data. So an entity relationship diagram has a lot of components, and one of the components is the entity. This is exactly what you're trying to model. This can be a user. This can be, let's say, in my case, it can be a course. It can be a course material. They are all entities, and then each entity has attribute, and this attribute can be the characteristics of the entities that you're building. For example, you have an entity user. That user might have a name, and that user might have an email. The user might have a password. The user has a lot of characteristics, and these characteristics are called the attribute. And I will show you how this attribute looks within this. And then you have a relationship. So let's say when you're creating your database, you need to also consider relationships. Let's say for my case here in this software, in this feature exactly, I have a course, right? And then I have a course material. So a course can have many course material. Let's say if I have a course here, and then within that course I can easily add other videos. So these videos belong to a specific course. I can add videos. I can add let's say PDFs. I can add any resources to my course. These are the course material that belong to the specific course. So they are modeled using relationship. And then we have the cardinalities. And the cardinalities, these are the numerical constraint or relationships such as one-to-one, many-to-many. So let's say you have a relationship. This relationship, you have to model them using cardinalities. And these cardinalities can be, let's say, a user can have many courses, right? And this is one-to-many relationship. So you model them using these cardinalities. Or you can have one-to-one relationship. You can have many-to-many and belongs to many. Yeah, this is it. So why do you need an entity relationship diagram? Is database design. It helps you organize ideas and catch logical flows before writing code. Before you start writing anything, you need to map out the structure of your database. So it helps you to visualize that. And then also a communication, it provide a common visual language for technical teams and non-technical stakeholders to discuss the data needs. So if you are trying to write out the data requirements, you will exactly need an ERD. So and then the final purpose is like the documentation and the troubleshooting. It serves as a reference for existing system to make it easier to find bugs. Let's say later you build a product, and then later you find a bug within production. So how will you start debugging that? You go and look into logs. Let's say I looked into the logs of my application, and I found out that the users that I have made the application where users can add something, users can let's say insert data, but the column doesn't exist. So it will help you when you go back to your ERD. You find out, oh, this column does not exist, but it exists within the. I have a field in the front end that adds data to that column. So I have to fix that bug. So this bug you catch that bug when you look at your ERD. So we have among this diagram also we have the activity diagram. This is not the final one, but I have the activity diagram. And before I go to because this looks small, let me first show you from the diagram here. I think it's somewhere here. The ERD, yeah. So this is one of the ERD that the ERD there, and then what I have here is the user. This is basically the ERD of the course material feature. So I have a user, then the user has a course, and then the course has course material. And then here is how I show the cardinalities. This is how you show the cardinalities. Let's say here I'm showing that this user has many courses. A specific user can have many courses. And here these are the attributes of the user, like the name, the ID, the name, the email, the password. And then here the PK, it means that this ID is the primary key. And then here this is the primary key. And also here user ID, which is FK, this is foreign key. Yeah, and these are the attributes. So this is also one of this is the course material, and I'm saying that a course has many course material. And this is the cardinalities that I was talking about. So this is the logical view, the logical level. I mean, when trying to design an ERD, you have 3 levels. You have the conceptual level, you have the logical level, and then you have you have the physical level. The logical level, you have to only include specific stuff such as the methods, the entities, the attribute. You have to include them, but you don't have to include how will that database be implemented. That is in the logical level. And then in the Physical level is where you have to include the real database implementation. You have to include the data types, and you can easily translate that the logical level into database, into a physical database immediately. So this is it with the ERDs. Let's go to the next required diagram, which is the activity diagram. So an activity diagram, this models how the data moves within a system. A very simple definition how these models how the data move within a system. We take example from our system, but before we go to that, let's see the required components. We have the actions. These represent a specific task or an activities within a process. These are we call them actions. And then we have control flows. These are the arrows that shows how the process in the how the flow of the process in the system. Okay, and then we have the start and end node. So this is the start and this is the end node. So let me show you how this works from here. Also, I have one activity diagram I've drawn here. This is example of user authentication activity diagram. I will show you with this course material feature. So let's say here this is the starting node, and then here these are the actors. They have a client, and then we have what? The auth service. The client is basically your front end. So let's say within the client here, a user can log in, right? A user can send their information like their username, their email, their password, and then this information is sent into the auth. This information is gathered and then is sent into and then is packaged into auth information here, and this auth information sends a request to the auth service here. So this is how you send the request with this this rectangle, and then this shape looking like a bullet, and then here, as you can see, this shape is like waiting to receive that information. So it receives it from here. You send the auth information such as the username and the password, and then it is received in the auth service. So what this does is that here you have this block. This is validation block. Let's say validate the username if the username exists and the password, and then here this triangle, this diamond shape is used to let's say check the information or validating the information. And then you have two arrows, one point going back and then one still coming in. So one still continuing. So if here we'll check if the username and the password are valid, it will immediately authenticate the user, right? And then if they are not valid, it will send the error back to the client. That is, I think this arrow pointing this side, that error invalid user information. And then the application will terminate. This for the termination. And then if the user is authenticated, okay, it will send back this to the client that the user is authenticated successfully, and then save the information, the session within the cookies, and then terminate the application. This is basically, it shows, I think, as from the definition, this shows the flow of data. The data started flowing from client, it went to auth service, it validated it, and then it sends back the response. This is the main purpose of this diagram. And then let me see what diagram next again. Okay, but let me explain with this feature, because I have several activity diagrams here. This is creating a course, this is creating a course, and then this is course material. This from the point of where from our service, from the service that we are building or the feature that we are building, this is how the activity looks like. We have the actors, we have a client, we have course material, and then we have the YouTube API. Okay, let's start from the beginning here. Let's say a user tried to create a course, or let's say a user is working now. We are working with a course that is already created. So the course is already created. What do we need to do? We need to search for a course, right? You search for a course. You type in the input, you search for the course, and then the query is gathered and then is assembled here. this query is then sent to course material service. The course material service here what receives that query. What it does is that we have a block here. This block gets that information and then sends it to your YouTube API. So it sends your query to YouTube API to get that course. So what the YouTube API does is searches for that course and then sends it back to the course material service. The course material service receives that information. Let's say you search for Go Fundamental, and then or you search for whatever video that you need to add as your course material. So you receive it and then you send it back to the course material. Send it back to the client. The client receives it and then displays it to the user. So the user will now see, okay, what I search is here. Maybe I search for, let's say I search for system design course, and then I got these courses of system design. Then I will have a list of videos about system design. Then I'll click one that I need. All right. After clicking that, you can now send it. You can send a post request now to the course material service, and then the course material service saves that course data within the database. Basically, I'm using Postgres. Let's say it saves it in within Postgres database, and then sends back the response to the user, and the user receives that response that the course is being saved, and then the application is being terminated. Basically, this is the flow of how a course working with course material is. So this is with the activity diagram, and then I think one of the important diagrams here we have is the component diagram that you need to also nail down in order to turn your idea into technical requirements. So component diagram is basically a high level view of how a software system is divided into physical, logical blocks, and how those blocks communicate with each other. It's less about how the code works, and it's more about how different pieces of puzzle fit in to form a whole system. Where is it? Let's go back to it. Here. Yeah. So a component diagram basically allows you to get the overview of exactly what you're going to build, how the components within your system are going to communicate with one another. Let's say you have the client, and then you have different services like the auth service, you have the database, you have the S3 bucket where you store your assets, and then you have let's say you have several services. How will these services communicate to each other, and how will they require data from one another? So this is you need a component diagram to model this. Let me show you from one of my components diagram here. I think this is one of the components diagram. And we use this because it has the repository pattern. So this is the component diagram. This is a component. Let's say a component can be like a service, or it can be anything. It can be a block of code, it can be a function. So here I'm using, in the architecture I'm using to build this feature is repository pattern. I will talk more about repository pattern in the next phase of this. It's actually not in the documentation phase, but it is in the implementation phase. That will be the next live stream. But basically in repository pattern you have a handler. A handler is used to handle the HTTP request. If it is an API, you can handle like the get method and the post, the delete, the patch, all these methods. And then what the handler does is that the handler communicates with the service. Let's say the course material service here. So this service is only used for putting your business logic only. You don't have to put your database logic. You don't have to put anything. You only have to put the validation logic. The validation logic and the business logic, or what you're exactly implementing. So this service communicates with the repository, and this repository is this component here is where you communicate with the database. As you can see here, the repository communicates with the course material API, now the YouTube API, and then also with the model or the database. And then the last component here is the entry point, which is mean.go. That is where everything comes together, or it bootstrap everything, so that when you run mean.go, all the files are being run. So this is basically the component diagram. The components diagram allows you to break down your application into actionable things that you can later implement. Let's say I already broke down all whatever thing that I need, like the handler and the services, the repositories. So in mind, I have already visualized whatever thing that I need to do. So the next thing I can do is that I have to, let's say, take each part and then put it in my technical requirements document, as I'm going to show you from here. I think I have it here. Yeah. So let's say you are done with all this documentation, you can have something like this. Like this is an example of a task that you can implement. After getting all this document, you have you have a picture in your mind of how you can implement this. So you can lay down whatever thing you want to implement. So these become your functional requirements now. So and this is the ID of the requirement, fr-1 -0. This is a functional requirement. Let's say create a model for a course material. So I already have the database requirement laid out. So I have in mind that I can create a model now. And the fields include video ID, title, YouTube ID, description, thumbnail, duration, upload date, course ID, lesson ID. So all these are supposed to be inside. They're supposed to be inside your technical requirements document. And let me give you an example of the exact technical requirements document that I've created based on this documentation, which is in Confluence here. So this is the technical requirements document. So within my Confluence, here this is how the technical requirements document looks like. Here, technical requirements specification for focus flow course material feature, right? You have to define the purpose, which we talked more about it there. And then here, this is the convention that I'm using. Shall refers to a mandatory requirement that the user should be fulfilled during phase 1 of the implementation of the platform. Yeah, and then I have a should, I have may, I have to be implemented. So let me go. This is the convention also of how I'm trying to map out this. Like function fr-xx, it means that functional requirement, and then the ID of the functional requirement, maybe 01, 02, and then nfr, this is non-functional requirements, and then the number of the non-functional requirement, and then ir-xx, it can be the interface requirement. This can be the UI requirements that I need to implement, and then I have the dr. This is the data requirements. So here, this is, you have to put the stakeholders, and then so the feature is scope. You need to also define the scope of the feature. What are you going to implement? This is the scope. I think that the font is too small. I have to also get rid of this. Okay, like this. So all this doesn't matter, but let's go direct to the function, to the requirements. How exactly these are the requirements. So I have the functional requirements here, and what are the requirements? fr-01, a user shall search for a YouTube video by initiating a GET request to the course material service API, and the API will proxy the request to the YouTube and fetches that video. Simple. This is a functional requirements. This is one functional requirement based on all this documentation. You have to put all this documentation, and then you get this a simple piece of text. So without all this documentation, you cannot manage to visualize what you need as your functional requirement. So that's why the documentation is very important. So it's now kind of making sense that how you translate the idea that you have into implementation. So this is also another functional requirement that I have. A user shall attach a video by searching for a specific course by making a post request to a course material service with the course UUID. So this is the functional requirement. And then here I have the database requirement, the first database requirement here. A course material search data and the search result shall be saved within the database, and the fields include, yeah, this speaks for itself. These are database requirement. And then here, these are the tasks that need to be implemented. Okay, after getting the functional requirements and the database requirement, you need to now break down this task. So here you already have a task. So this task you can easily now, let's say you're working in a company as a senior engineer, all this documentation work will be yours with the project manager. And then later you have to create this you create this task based on the documentation, based on the functional requirements. You have this task, and these tasks are recorded in Jira. I can show you how it is being recorded here. They're recorded in Jira. Jira is a project management tool. And then these tasks are then assigned to specific developers to go and work on them. So that's why they say, that's why when you hear like people saying that software engineering is dead, they're not really meaning like from the implementation. They're not meaning from the documentation and the idea and the breaking down of the idea into technical requirements. They are meaning software development is dead from this point of let's say getting this requirement, because I can easily take this requirement that I've already created. I've already laid out the infrastructure of everything, and then just put this into any AI model, or I can use any AI agent to build for me this. But AI can not do the work of, let's say, this documentation for you. AI cannot sit down and say, I need to build this software. I cannot think of, I need to, like, let's say, get the technical requirements document. I need to piece all these things together. No, it can only help you in doing that, but it cannot implement that by itself. That's why they say this is the era of now getting deep into software development. You don't have to just stop within this shallow point where you have to just get this task and then implement them. No. So I have another functional requirement task 2, that is that is create a repository with a method called search video that accepts a string and then search for that video, send the search to the YouTube API by making a request and receive that data. Okay, this is also one task. So after doing all the documentation, after writing all the functional requirements, you end up with this kind of task. So you need somewhere to save this task. That's when Jira comes in. Let me open my Jira here. I have a backlog in Jira. So this is it. I have implemented most of these tasks, so that's why you're seeing them done. So within Jira here, you have 2 sections. You have the board and you have the backlog. Backlog is where, like, let's say the developers, the people using your mostly the users don't access Jira, but it's only the developers. The developers get the tickets, get the support tickets, and then just put them within the backlog. And then the project manager prioritize all the tasks in the backlog and then assign the task to the user. So let's say I've already broken down the application within this task. I can just come here to create. Then I can either create a task, or I can create as you can see here, I have functional requirements, or I can create a user story. So I have here user stories that is based on this feature that I've already created. Let's say, let's see with this user story. So as a user, I should be able to search for a YouTube course so that I can be able to add it to my specific course, right? This is the user story, and this user story needs task, and this task this is what we laid out from this documentation. That is here: implement a YouTube search, create a course material repository, implement the service, implement the model, and implement the database. All these are part of this all these tasks are part of the user stories, and all these tasks are laid down here within our technical requirements document. So that's where you see the importance of documentation. Now that I have laid down everything and I have all my tasks within my technical requirements document, and then I got all these tasks, I place them in my Jira backlog, and then Here, most of these tasks I've already worked on them, so that's why you're seeing done. Let's see what are the implementation of this now. I can go back to my code here. Can go back to the code, and then I can show you what I've implemented. These are the things that I've implemented. So this is the whole project. Actually, this is the whole service, and this service, these are the things that I have within that service. The first thing I have is this is to go specific. I have here the CMD, and then I have the entry point. Here I have the documentation. I will show you how this documentation is. And then I have the handle. As I said, I was using the repository pattern. I have the model, I have the repository, and then I have the routes, I have the services, I have the .env. This is basically the handler. Let me show you how this works instead of showing you the code. Let me first, because I'm running it within Docker. I say Docker compose app. So it's starting the database, and it's starting the application. Yeah, it's being started. The first thing here is, I think I have to get the documentation. And one thing that I forgot to talk about is, let's say whenever you're building an API, you need to document your API, because you're not the one going to use that API. You might give that API to the developers to use it, right? So you need a documentation for it. Let me open it here in localhost 8080, and then I need the Swagger documentation. Yeah, this API is part of the application. Yeah, here I'm using a framework called Swagger. What this Swagger does is that it documents the API, so that, let's say I'm working within a team and then I have a front-end team, I can just send them the API documentation, and then they can follow from this documentation. So what I have here is that, let me try to increase it. This is how to make a post request to course material, and this is how it is done. Let's say accept the list of course material, and then save it. This is exactly, let's say you already searched for the video you want, and then you got those videos, you selected all of them. Here you can make a post request immediately to course material server, and then save all your videos. And then this is how it's supposed to, these are, let's say these are the exception in case you get errors. And then here you can make a get request also. This is how it is. Course materials, guys. I will show you how it works in real life. And then also here, if you're getting a specific course, and then here, if you're specific course material, here if you are trying to update a course material, basically all the crowd delete. And this here within this health, we use this to check the health of the API. Let's say later I'm trying to set up a load balancer that is supposed to route traffic to the healthy API. So this API I might put them within, let's say I have 3 replicas in a Docker container, let's say. Then I will have a load balancer logic where it will make requests to the healthy API every time. So it will check, is the API healthy? Yeah, then it will allow users to route traffic of the users to that API. If it's not healthy, route traffic to the next server. That is just the use of the health endpoint. So let's see them in real life. I have them here. I have a collection in Bruno that does that. Course material. Here, let's start from, I think it's better to start from search. Okay, search is here. Let me search for a YouTube video here. So this is the URL of search. I have here get request to the base URL. Base URL is basically localhost port 8080 /API/course/search, right? And then when you're searching, you need a query. So this is the query here. You can search anything that you want. Let's say this search basically goes to YouTube. Let's say I don't need to go tutorial here. Let's say I'm searching for system design. system design like this, right? And then here, this query string is to show me to give the maximum number of results, because when you're designing your API, you need to put in mind your, let's say, the efficiency. Let's say if I did not put the number of requests, it might end up searching all the videos that are about system design, and it might slow down the system, you know. That's why you need to have a context of what you're doing. So within 1 second, I get all the 10 videos about system design. This is basically, let's say, when a user is trying to search from the application. When I connect it to the front end, this is basically what is going to happen. And then after doing that, the next step is, let's say I search for this video, I need to add this video to my, I need to add this course material to my course. So that's when it comes here to course. Let me go to course material. Here, post method to add a course, right? So I have this to add a course. Let me change this course ID. Let's say this course ID number 2, and then this, let's say this example of the course that I already searched, and I want to add it there. Just trying to change some stuff from here. Yeah, let's say this is the course that I've already searched, and then I need this course to be saved to the course material database or server. So let me try to save it. Well, error duplicate. Okay, I think I have duplicate here. This course is already being saved. Okay, let me just get whatever here. Okay, and go back again. I think it's this lesson ID. Make it any number. You don't need to have duplicates. That's why save this. Still okay, it's already being saved. So I already saved this course now. Save this course using the API, and then you can perform all this crowd, all this crowd, like delete, put, update, patch. All the crowd is being implemented here. Here is to check the health. Let's say I try to check again. Yeah, it's showing me that the application is healthy, and it's giving me the timestamp. So this is basically the API that I've implemented based on this documentation. To recap this, I started from having a PRD. From the PRD, that is the idea. From the idea, I went to the technical requirements document. I laid down I removed the gap between the business logic and the technical implementation, or I turned the business logic into technical and actionable implementation. After that, I have to lay down all the diagrams needed, such as the sequence diagram, the context diagram, the components diagram, the ERDs. Yeah, and after doing that, I have to put all this within my technical requirements document, all the tasks within the technical requirements document. After putting these tasks within the technical requirement document, I have to break down this task into simpler tasks that any developer here can do, even AI can do it. So after doing that, I have to implement them using Go, and I implemented them using the repository pattern. After implementing these, I test the API using Bruno. After testing the API using Bruno, I have to create a documentation using Swagger. This documentation allows me later allows the front-end developers later to connect the API to the front-end. So this is basically what I have done, and in the next live stream, I will be talking more about how this is being implemented using the repository pattern. What is a repository pattern? What is a service? What is a handler? And why do you all need this? And I will also show you more about Gene. That is the library from Go used to build REST APIs. So this is it for this live stream. See you in the next live stream.